So it comes into that we can solve some of these algebraically as well. Okay, and algebraically, if we solve them by algebra, we're basically undoing the calculation. So we can undo this calculation by doing plus 9 on both sides. And we undo squares by square rooting. So we end up with x. And when we undo by square rooting, we have to make sure that we keep both the plus and minus. In this case, since it's a perfect square, we get plus minus 3. Now, this quadratic we cannot solve by algebra very easily because it's hard to get rid of the minus, times, and squared. In fact, it's not so much the minus, but it's the times 3 and the squared is happening on the x at the same time. And we cannot get rid of a squared with a and a times at the same time. So basically, what makes equation B much harder to isolate x? Well, we have a square and a 3x together. Which cannot be undone at the same time. Okay, so this becomes an issue here. So if we knew how to just make this into a times or just into a perfect square, maybe we could solve this. And I seem to recall that we had a way of making this into a perfect square to be able to undo the square.